We're given a polynomial, and this polynomial that we have currently is a polynomial with real coefficients. And at the same time, one of the roots that are given to me is re to the power of I theta, so this is a complex root. So we are faced with two pieces of information, a polynomial with real coefficients and a complex roots, and this can help us to deduce the other root, which is going to be the conjugate of the first complex roots that is given to me. So for the second root of this polynomial, it is going to be re to the power of minus I theta. And now we have two roots. We will be able to form the quadratic factor. Let me show you the format of this quadratic factor. So the quadratic factor of this same polynomial pz, this is going to be composing of two linear factors. One will be z minus this root minus re to the power of minus I theta. And the other one will be z minus the other root, which is minus re to the power of I theta. Let's try to expand this. Our aim is to try to get an expression that looks like the one that the question wants us to show. So z times z here is z squared. This multiplied by this is minus re to the power of I theta z. And this multiplying by this is minus re to the power of minus I theta z. And this multiplied by this is going to get us a plus re to the power of minus I theta, multiplying this to re to the power of I theta. So this is equal to z squared minus, I'm going to factorize out r. In fact, I'm also going to be factorizing out z. So what will be left within the bracket here will be e to the power of I theta plus e to the power of minus I theta. Then plus r times r is going to get me an r squared. Then this multiplied by this will be e to the power of 0, which is going to be equal to 1. We're going to write that down later. So z squared minus r. As for this over here, I'm going to re-express them as a trigonometric form. So for this, in the trigonometric form will be cosine theta plus I sine theta. As for this, which is the conjugate of this, will be cosine theta minus I sine theta. Then multiply by z plus r squared e to the power 0 is 1. So I'm going to write it down here. So this will be z squared minus. As for this here, we can see that plus I sine theta and minus I sine theta can be cancelled. So I'm going to be left with 2 cosine theta in the bracket here. Multiplying by this is 2r cosine theta. Then I'm going to put a bracket here because actually we are going to be showing this, right? And here there's a bracket, so I'm going to also put a bracket here. Then multiplying this by z. Then plus this r squared times 1 is just r squared. So this is what the question wants us to show. For part 2 over here, we are going to make use of the result that we have gotten from the previous part, because now in part 2, we are given two roots. And please take note that these two roots are not conjugated of each other. So what we are going to do is try to match this to the result that is from the previous part, which means that if I'm given a root of re to the power of I theta, we can actually very quickly derive the format of the quadratic factor that is related to this root, which means that if I were to try to look at this based on the previous part, square root of 3 is going to be r, and theta is going to be equal to pi over 6. So the quadratic factor will look something that is like this. It is going to be z squared minus 2 times of r. In this case, r is square root of 3. Then after that, cosine of theta. Theta is equal to pi over 6. So this multiplied by z plus r squared. R squared is going to be square root of 3 squared. So this is equal to z squared minus 2 times of square root of 3. Cosine pi over 6 is square root of 3 over 2. Z plus square root of 3 square is equal to 3. So this is going to be this minus away. Actually 2 I shouldn't be writing because 2 and 2 here can be cancelled. So square root of 3 multiplied by square root of 3. So this is going to be equal to 3z plus 3. As for this, we are going to find our new r and new theta, so I can make use of the previous part. So for this, the new r is going to be equal to square root of 2, and the new theta is going to be equal to pi over 6. So this is going to be equal to z squared minus 2 times of r, which is square root of 2, then cosine of theta, which is equal to pi over 4, then z plus r squared. So it's going to be square root of 2 squared. This is equal to z squared minus 2 square root of 2 cosine pi over 4 is 1 over square root of 2 multiplied by z. Square root of 2 square is equal to 2. This is equal to z square minus square root of 2, and square root of 2 here can be cancelled. So minus 2z plus 2. So now we have two quadratic factors. By multiplying them together, we will be able to get the expression for pz. So that's what I'm going to do here. I'm going to take this, which is z squared minus 3z plus 3, multiplying it to z squared minus 2z plus 2. Okay, this will give me pz, but let's just do a quick check, okay, because this is z squared, as in like the coefficient of z squared here is 1 and 1. So here is z to the power of 4, its coefficient is 1, so it is all right. I can leave this as it is. If, for example, the coefficient here is, for example, let's say 2, then we will have to write down an extra 2 as the coefficients in front. But anyway, this is just going to be 1 as the coefficient, so I'm going to leave this as it is. I'm going to expand this. So z squared times z squared is z to the power of 4. This multiplied by this is minus 2z to the power of 3. This multiplied by this is plus 2z squared. Then this multiplied by this is minus 3z to the power of 3. This and this will be plus 6z squared. This and this will be minus 6z. This will be plus 3z squared. This and this will be minus 6z. And this will be plus 6. Let's simplify this. We have a z to the power of 4. As for z to the power of 3, we have this here and this here. So if I were to add this together, it will be minus 5 z to the power of 3. Let's work on z to the power of 2. We have this, and this. So 2 plus 6 is 8 plus 3, this is 11. So plus 11z squared. Next, let's go for z. We have this and this. Minus 6 is minus 12. So minus 12z. And finally, the term that is independent of z, which is just going to be plus 6. So now I can try to match this to the format of the polynomial that we originally was given. And now we can find a, which is going to be the coefficient of z to the power of 3. So a is minus 5. We can find b, which is the coefficient of z squared, that is going to be 11. And c is going to be the coefficient of z, which is minus 12. And d is going to be this term here, so it is going to be equal to 6.